Good afternoon. My name is Sandy Baris Shigota, and I will be presenting the research on artificial intelligence application in determining industrial robot manipulator dynamics that was performed by me and my colleagues, Dr. Nikola Angelic, Marko Glučina, and Professor Dr. Zlatan Car at Faculty of Engineering, University of Rijeka. To introduce the problem, the dynamics modeling is very important in determining how a robot will perform in motion by calculating the torques of each individual joint. The standard process for this is analytical and utilizes Newton-Euler or Lagrange-Euler algorithms to generate the equations for each individual joint. While these equations are very precise, they could be very computationally expensive, something that we can see here. This example for a 6 degree of freedom industrial robotic manipulator equations. In each of these equations uses a shortened notation where S stands for a sign of the joint given in its index, position of the joint given in its index, and C stands for cosine. As these equations can take a while to calculate when we are attempting to determine the torque, we have considered using artificial intelligence methods, namely multi-layer perceptron of feed-forward artificial neural network that has been adjusted using a random hyperparameter tuning and validated in a 5-fold cross-validation schema. The dataset consists of 20,000 data points which were generated using the previously shown equations for ABB IRB 120 manipulator and uses position, speed and acceleration of each of the joints as inputs and individual joint torque values as an output, in addition to the total torque of the robotic manipulator, which is calculated as the sum of absolute values of individual joint torques. The results achieved are promising and show that the coefficient of determination we can achieve for individual joints is above 0.95 with mean absolute percentage error below 2%. That is high enough for high-level approximation, for example comparing which of the two trajectories will have a lower torque, will generate a lower torque. Sadly, the total torque model shows unsatisfying performance with the used methodology. One of the important things to note is that the models generated using MLP show a significantly faster prediction or a smaller prediction latency in comparison to the previously shown analytical models, with the prediction latency being about 6 times smaller. Well, this doesn't seem like significant time savings for a single calculation. We are planning on applying this in multi-agent systems for optimization, which will use a large number of agents and a large number of iterations, so these time savings could be expanded by a few orders of magnitude. With that, I would like to thank you for the attention, and on the right you can see my contact in case you have some further questions beyond today, as well as acknowledgements and references to the research, to the related research. Thank you once again for your attention.